when schedule gets created, the date D member also gets created. And which constructor gets called? The answer is this constructor gets called because date D is created without passing any arguments to the constructor. This is the correct constructor. Correct constructor, which doesn't require any arguments. Okay. So let me go ahead and do it the other way. M is getting passed to the constructor of D because this is an initialization list. That's how initialization lists work. It allows you to use a constructor other than the default constructor for members of, in this case, the schedule class. So the member D, when it gets constructed, the value 3 will get passed in as, and it's an integer, so we know that this constructor will get called instead. Are we all set?
Yep.
Video? Okay. Right.
Can we
Yeah?
turn these lights off?
Yes, the best one are rear spots.
So,
Yeah, perfect.
okay.
Okay. No, we're going to go faster. I think we can finish 6, 7, and maybe even 8 today. And then we'll do arrays and pointers next week. Okay. Const member functions. Functions in classes can be declared and defined using a const within their header. Okay, the function header is, remember this part of the syntax. Const goes over here. And what this says is that this function will not change the object that the member function is being called against. Okay? And cannot change the value of data members in the class. They also cannot call member functions that are not const. Okay? So for example, the date class looks like this. So in this case, the print function might make the good candidate for a const member function because we can print out the date without changing any of the members. Okay? So if we wanted to do that, we would put const here in the class definition. We also put const here in the function definition. Okay, assignment. Assignment is tricky business, and we will talk about that soon, but not yet. However, if our classes do not contain pointers, we can use assignment to copy objects from one class to another, and it does a member by member or a bitwise copy. Okay, so for example, we create an object of type date called today and another one called tomorrow. We can assign tomorrow to today, and this is safe because, let me go back up here, right, we don't have any pointers up here, they're just integers. We can just copy the memory and everything would be great. Okay. We can also use assignment to assign literal values. Remember, a class literal value is specified like this. Okay, so it's the name of the class and then arguments which would get sent to the constructor. So this will construct a temporary date object which is then assigned to an object of type data. And this is not initialization, it is assignment, because it's not a definition statement. Okay. Class objects as data members. Almost certain that we went through this. Okay, so this is kind of what we were talking about before about when you have an object of class type which is a member of another class. So we have the number class here, which just has int, and then we have a polygon class which has number as one of its members. So side length is of type number. Okay, and we can do this. This is in fact what we just talked about, because number has a default constructor, and so when we construct a polygon, we can easily construct a number without having an initialization list. Okay. If we didn't have a default constructor, we would have to have an initialization list for the polygon constructor. Okay. Which is what we just talked about before with the date and schedule thing. Okay. Class scope. All declarations made within a class definition have a class scope. Identifiers with class scope are visible to member functions of the class. They are hidden from functions outside the class unless the scope can be resolved by the use of the member selection operator, that's the dot, also an arrow member selection operator, or the scope resolution operator, that's the two colons. So, just to recap, if the member is inside of a class, you have to use one of those methods to resolve it if you're outside of the class. Okay. When an identifier is specified using a member selection operator, it's resolved to be a class member. Otherwise, the ordering is used, the following ordering is used. Local variables first, class variables if within a class next, and global variables last. I think I have an example of this. Oh yeah, this is an example of how this works. So you have a global variable x. You have a class member variable, which is also called x. Okay, and here we have a local variable called x. So when I do this, what does it mean?
Set the local.
Yes, in fact, it's right there in the comments. But if you didn't have the comments, you could go up to this priority chart and say, oh, local is priority. Okay. If I wanted to use the class variable, I could resolve it with this colon. Say that it's the x which belongs to the polygon class. That would allow me to access that x. If I wanted the global ones, you'll see this fairly often, in fact, this colon at the beginning. That always means a global variable of some sort. And it's used with functions as well, just to make it clear. It's not just variables, also functions would be resolved this way too. All right. Static members. Most ordinary members are defined once per each object. So if I create 10 date objects, each of them probably has a month. However, we can also have static members which are defined once for the entire class. So no matter how many date objects I create, there would be only one copy of this. It's called a static member. Okay, they can be either data members or member functions. The static member is qualified with the static keyword. Be careful, static means multiple things in C and C++. Okay, here it is a static member. Static data members must also be defined globally to allocate memory for the object. You must use the scope resolution operator to read and write a globally defined static member from outside the class, and you should not use the static keyword in the object or function definition because it means something else if you do that. All right, now that we got the rules out of the way, let's look at an example.